Okay, this is the new thing. Here's where the multiple solutions come into play. You can see this angle that we got, 72.9. Well, now we have two angles. We know this angle is 35 and this angle that we just found is 72.9. We don't have to do a lot of crazy math to find the third angle, because you know all these three angles have to add up to 180. So to find this third angle, you can easily just take 180 and subtract 35 and subtract 72.9. So the third angle should be 72.1. This third angle should be 72.1. This angle would be 72.1. This is one solution. Okay, this is one solution. Now, how do you find that second solution? Because these triangles will have a second solution. How do we find that second solution, guys? Remember the angle that we found? This angle, it has another possibility. How do you find it? You take 180 and subtract this angle, 72.9. And whatever you get, in this case 107, this 107 represents my second solution. Yes, yeah. Just subtracting 180 from 72, that'll give me a second solution for this angle.
Why are you doing
that? That'll be the second solution to this triangle.
How do you know which angle you're supposed to subtract it?
How do you know what?
Which angle you're supposed to subtract?
So
the first one you did, or
the first one that I found. So the first one that you find, that's the one that you subtract the 180 from.
So whatever you find,
Yeah, 35 you cannot change it because they gave it to you to be 35. So 35 you cannot change it. These two are the unknown. But the first one that you find, that's the one that you want to change it.
I'm trying to explain what you're reading.
So the first one that you find, that's the one that you want to change the degree. And you find it just by subtracting 180 from it.
and that's, what did you say that was called? A multiple solution?
A multiple solution, yeah. So I'm going to take 72.9 and I'm going to subtract 180. So I get 107.1.
You got negative.
I'm sorry, yeah, I was supposed to do 180 minus 72.9. So 107.1. So yeah, the second solution for this angle will be 107.1. So what about the top one? Yeah, this will also have a second solution. Okay, the second solution for this one, well guys, 35 is the one that's going to stay the same because they gave it to you to be 35. So this one that was given, you cannot change it.
The only one you can change is 32.9 and 72.1.
Yes. So to find the third one now for the second solution, you again take 180 and subtract 35 and subtract 107.1. And that'll give me this angle will be 37.9. So the second solution for the angle up here will be 37.9. So let me draw out these triangles that we're getting, okay? Just to show you guys kind of like a picture of it. Okay? So let me draw out the first triangle. Okay? They are not going to look identical, okay? But if I were to draw the triangles, again, the angle that measures 35, that's not going to change. It'll stay as 35. This angle doesn't change. For one option, the first one that we found, This angle is 72.9. And this angle up here is 72.1. 526. This was solution for the solution for the first triangle. Because we got different angles, it means that there's actually a second triangle. Again, the 35 does not change. The 35 does not change. And the second angle that we found by subtracting 180 to 72.9 was 107.1. And then this one up here was going to be 37.9. So technically, guys, out of this one problem, we actually get two triangles like this. Okay? So the second solution, this one, the angle that we find first, that one helps us find the second solution. We just subtract 180 from it, and that'll give us, in this case, 107.1. And you guys can check these two triangles. The angles should add up to 180. So let's look at the first one, 35 plus 72.9 plus 72.1. And that gives me, as you can see, 180. Then you can take the angles for the other triangle. It's 35 plus 107. Huh?
Does it matter which one we use?
Well, these are the two solutions. So the Alex is going to ask you, give me all the solutions. So you want to, I'll show you exactly what Alex will expect you to put in.
Then can we do this for a triangle? That's not now right.
No. Again, 180. I think this is only for the law of sines. I'll check the law of cosines in a minute. The process should be the same. Mr. Tafoya speaking? Yes. Yeah. No problem. Daniela, te hablan. Pero se está grabando todo.
Por eso te dije que grabara.
Okay, muy bien. Guys, and technically, well, Daniela, technically that's it. We still have to find the missing side length, because I gave you two. Look at the original triangle. I gave you two side lengths. Remember?
Just record those for us and
Yeah. Yeah, guys. So technically, guys, these two triangles still have the same side lengths that I gave you. Alright, so these two triangles, guys, they will have different angles. Okay, guys, excuse me. These two triangles, everything that you see in orange, that's what I originally gave you guys. Everything that's in orange, that's what we started with. And if you notice, these two triangles, the only thing that have changed were the angles. Okay? Now, the problem asked me to find all missing sides and all missing angles. I still have to find these two side lengths here. Okay? But now, look at this. Now that I have the two triangles, I can use the law of sines to find the missing side lengths. Finding the missing side lengths. Again, hope at this point you guys should know how to do this. But let me do it just in case. Okay, I'll use brown. So let's find, let me label this one as A and this one as B. Okay, so I want to find these two side lengths. Alright, I'm gonna have to use the law of sines. So sine of the angle that's opposite to A, that would be 72.1 over A. equals, and now I can use 72.9 and 15 or 35 and 9. I'm going to use 35 and 9. It has simpler numbers. So sine of 35 over 9. So that's the setup to find the answer for the first one. The setup to find the answer for the second one is going to be identical. Sine of the angle that's opposite to B, angle opposite to B is 37.9. So sine of 37.9 divided by B equals, and again, I can use the 35 and 9, or I can use 107.1 and 15. I'm going to use the easy one, 35 and 9. So sine of 35. Again, if you're wondering why 35 goes in, 35 goes in because it's the angle. Right, Jasmine?
Yes.
Divided by 9. So that's it. This is the setup to find A and B. Let's find A. Let's find A. So I'm just going to flip both sides to put A on top. Just going to flip both sides to put A on top. So I'm going to get A over sine of 72.1 equals 9 over sine of 35. Then to leave A by itself, I can just multiply both sides by whatever I have under A. So to leave A by itself, I'm going to multiply both sides by sine of 72.1. And also this side, I'm going to multiply also by sine of 72.1. So on the left side, the signs will cancel out, leaving me with A equals, remember the sign multiplies to the top, that'll give me 9 sine of 72.1 over what I have on the bottom, which is sine of 35. Oh, it is 9, sorry. Oh, at least it's a 1, so you can make the 1 into a 9 pretty easily. So yeah, they were not supposed to be 1s, they were supposed to be 9s. Thank you. So yeah, just make the 1s into 9s. Oh, sorry, I wrote. Yeah, you guys know what it was supposed to be. Oh, look. I know. Now let's just wait 30 minutes for it to dry. Yeah, it was supposed to be 35. Okay, I'll just wait for it to dry. You guys know it's supposed to be 35. It's just not drying fast enough. I think you actually have to like. I think that helps. There you go. Yeah, once A is by itself, now you can put all of this in the calculator. So it's 9 sine parentheses 72.9, and then that divided by sine of 35, and we get 14.99. You want to round to the nearest tenth? That'll be 15. That'll be 15. So technically, A equals 15. And then for B, same. I don't want B on the bottom. I have to flip both sides to put B on top. It's the same process again. So flip both sides. So b over sine of 37.9 equals 9 over sine of 35. Multiply sine of 37.9 on both sides. And the sines 37.9 on the left cancel out, leaving me with b equals 9 sine of 37.9 divided by sine of 35. Then you can put this in the calculator. So again, 9 sine of 37.9 divided by sine of 35, and we get 9.6. So b equals 9.6. And that's it, guys. We found all the solutions, the two solutions, the multiple solutions to these two triangles. So the things that you would have to put into Alex would be the angles that we found, which we found this one and this one. For the first solution, you found 72.1 degrees. You also found 72.9 degrees. And you also found the side length A, which is 15 inches. So these would be the solutions for the first triangle. For the second triangle, we found 107.9. 0.1. We found 37.9. And we also found B, which was 9.6. Oh, these are degrees, right? Degrees. And then we also found 9.6 inches. So these will be the solutions that Alex will be asking you to find. We found two sets of angles and one set of side lengths. And that would be it. That's how you find that extra solution. Again, what led us to this was the original problem and the fact that we found the angle that we find first, we can subtract 180 from it, and that will give us this other angle. This other angle will belong to a second triangle. So the first one will belong to the first triangle, the second angle belongs to a second triangle. If it helps you to draw two triangles like how I did it, do it. I subtracted 180 from 72.9, and that's how I got 107.1. Yeah.